is going to ask you to go through the data design exercise that we're going to cover today in class and apply it to a problem statement that we're going to give you. And so these are several steps that you're going to be following to come up with a data design. When you first are giving a project, typically, because you either interviewed the client, the client's going to ramble on and on and on and on, and you're just going to sit there and listen and try to understand the business. And part of that process is try to identify the nouns, to try to identify the verbs, to try to identify the relationships between these language aspects of it, and you're going to try and formalize a design that captures what they're describing to you. And part of that process is identifying what the nouns are, what the verbs are. The nouns and the verbs are going to give us a clue at what are the data that we need to store, and what are the relationships. The verbs kind of give us what the relationships are between the nouns. Many nouns will end up being either properties or will end up being classes, right? And so we don't yet know that, right? So at first you'll come up with a very naive first approximation of what what a class diagram might look like, and as you go through a couple of phases, you'll identify that certain classes actually are not worth being classes. They should be perhaps attributes of some other bigger class, right? But at first you might not know enough from a particular domain, right? Maybe it's a new domain to you. You don't know if certain things are collections of other things, right? Or certain things are describing other things, right? You don't know these things until you become more familiar with the domain. And so there'll be an evolution of these nouns into classes and attributes and properties, or vice versa. Things that should be that you thought were attributes or properties actually should be classes. Then you'll start identifying things that have things that are in common with one another, right? That should be generalized into base classes, derived classes, and an inheritance chain. Then there's you'll identify that certain things have a life cycle or lifespan, right? Things that things are temporary, come and go. Things are more permanent, right? And so based on those kinds of based on that kind of lifespan and the relationship between other classes, you'll either use aggregation or composition, to represent relationships between parent-child relationships, that things are temporary or permanent. Again, an analysis between things that would be classes or attributes. Obviously, coming up with the correct data types to capture the data, and also how many instances of the various nouns participate in a relationship. Do we have one instance that is related to many other instances? Is there many-to-many? Is there a one-to-one? What kind of relationship? How many participate in a relationship? Some relationships might be redundant, right? That you could navigate from one part of the data set to another part of the data set in many different ways, right? And typically this might be a clue that your data types or your data model has redundant paths, and we want to try and remove those paths again to minimize the risk of inconsistency. And as you go, you'll a couple of the relationships will be fairly abstract, and you need to find a way that to make them concrete, right? That they need to be actually implemented in some low-level SQL schema. That there's certain things that in the UML class diagram you just can't implement with low-level SQL. So the reify step here will identify those things that either abstract classes or base classes, things that have no no mapping or association classes, things like that, right? They don't have a one-to-one implementation in SQL, right? You'll need to say, well, how is it that I implement this abstract representation in UML? How do I actually represent it in low-level SQL? So reify, you have to go through that. And as you decide that certain things should be classes, certain things should be attributes, decide the cardinality, whether you remove certain things because they were redundant. As you go, for each one of these, you need to provide a sentence or two explaining why did you make those decisions. Why did you remove this class? Why did you remove this relationship? And you say, well, it was redundant because if you follow this other path, it's already there. So you kind of those kinds of decisions. So here you should you should have a fair defense, right, on any decisions that you've made. Okay. All right. So the problem statement. For those that have taken web dev with me, you'll identify with this a little bit. So we're going to be creating an online content management system that allows you to drag and drop different widgets, create all sorts of web pages and each web applications that allow you to collect any number of pages, each page having a number of widgets. And you can have all sorts of widgets with raw HTML content or images or videos or all sorts of forms to be filled out. Very, very much what you might find in instances such as Squarespace, Weebly, Wix, right? These are all online content management systems, right, that allow you to build entire websites, right? And add pages to your website, move them around, and drag and drop all sorts of content in there. Each author or developer, you will have their own sets of websites. Right? So if I'm a designer, a website designer, I have my own website, and you have a set of websites. You might have your own set of websites, right? We're all working on our own websites, yes? And so if I log in, I'll see my set of websites. If you log in, you'll see your set of websites. And if I navigate to a set of websites, a particular website, it'll show me the list of all the pages that make up that particular website. Right? And if I go into a particular web page, it'll show me all the widgets in there, right? Maybe some headlines, some footers, some headers, some sidebars, some all the widgets that make up a page. So this describes a little bit the problem. It describes the users, what all the data related to a particular user, the addresses, the streets and city and state and zip codes, phone numbers and country codes and whatnot that make up a particular developer. Once they've created their accounts, they can start creating websites. If they select the website, they can inspect additional details about the website, such as some metadata, the date that it was created, the date that it was last updated, the current owner, the number of visits. So a lot of metadata about that particular website. Also, a developer might invite other developers to participate or help them out. So we could search. So we're adding a kind of a social networking aspect to this, where I might find other developers that might want to participate in helping me create websites. Right? And I can set up their roles, right? So whether they're only read-only, maybe I want them to be reviewers, right? And just they read the content and then they let me know about it. They can comment on it, but they can't actually change anything. Or I might give them write privileges. So I can give them different roles, and the different roles might have different privileges, right? So if I make you an admin, presumably I give you all privileges, right? If I give you a reviewer, then it's only read-only, right? So depending on the role, that might come along with different types of privileges. So we need to keep track of the different roles that we can give you, such as administrator, editor, or reviewer. And each role might have different privileges of being able to create, read, update, or delete certain aspects of a website. Right. So the developers can revoke different roles, and this is it could be as granular as the entire website, right? Or you can granularly say it only to a particular page, right? So you can read this page, but you can write this other page, right? So we can create all these types of associations on this particular user has this particular role for this particular page, right? We're not going down to the widget. It would be for the entire page. So if you have access to the entire page, you can do whatever you want. You can add and remove any widgets from that page. Anyway, so there are different types of widgets that they all have quite a few things that are in common with one another. For instance, they might have the position on the page, maybe the width, the height, X, Y position, maybe the style that says how it's rendered on the page, any like background color, foreground color, the fonts. So those things are kind of common across all widgets, right? But then you have certain aspects that are specific to different types of widgets, and so here are some of the widgets that we're looking at. For instance, the heading widget. It's a short piece of string with various sizes. It could be the size could be 1 through 6. And you're typically they're less than 256 characters. So giving you a hint on the size of the data that we're storing. There's a paragraph widget that renders long text strings, usually 4,000 characters plus. Image widgets allows rendering images. So you'll need, for instance, a URL, and whether it's aligned vertically or horizontally. Vertical alignment can be top, middle, or bottom. Right, so these are kind of clues of how you're going to represent these things in the data model. Typically, you would choose to do kind of like an enumerated data type, right, from which you can choose a valid set of values. Right. So I'm obviously not telling you how to do it, but these are clues, right, and that they can only be top, middle, and bottom. So presumably that would be a enumerated data type, right, from a set of known strings. Also, alignments can also be either left, center, or right. Again, that's looks like it's a enumerated data type. YouTube widgets. Renders are embedded YouTube video referenced by YouTube. Additionally, videos can be configured to have the following Boolean attributes, whether it can be embedded, true, false, shareable, true, false, expandable, true, false. Right. So these are again, expanding on the data model of capturing these things. There's so this goes a little further. It says pages and widgets can also be associated with all sorts of types of events that are triggers scripts that can operate on the pages and the widgets. Right? So, for instance, if you load a page, then certain events will be triggered, like on load, or if you click on something, or drag, or mouse your mouse over something, it triggers a whole bunch of events, right? So scripts can be named and can have a collection of steps. So it looks like there's a one-to-many relationship between scripts, right? And can have any number of steps, and the steps are executed in the order that were defined. Some of the steps they can have many different types of operations, such as add, subtract, multiply, divide. So index of, concat, substring, and Boolean operators, and then not. So these are some of the operations that are available in the scripts. Right. So this is asking you to come up with a UML class diagram, right? And the process you followed, right, to come up with that UML class diagram. Right. It typically starts with just enumerating all the nouns, right, all the verbs, as trivial as they might be, and trying to identify if from one noun to the next, right? If they're associated by a particular verb, are there just two nouns that are associated, or maybe there's three nouns that are associated with a set of verbs, right? Is it a relationship between two classes? Is it a relationship between three classes? And then you need some kind of mapping class in between. Right? So those kinds of things is what you would reveal from reading this paragraph. Right? And typically, there's the exercise would go both ways. You're giving a piece of text, right, and then you come up with a UML class diagram, or vice versa. We give you a UML class diagram, right, and you create a narrative. Right? So what does this, what kind of questions can you answer with this data model? So this one is we're going to be covering some of the techniques that we'll need for this assignment, right? On how is it that you would go about converting a this kind of paragraph into a data model. All right, and then you'll get to practice it in the assignment. Right. So this is going to follow for your project. You're going to follow the same thing, right? We're going to be asking you to come up with a narrative that describes the requirements for your project. Right? So early on, you'll be promising me lots and lots of feature sets, right? And all sorts of things. And as we progress, it might change. The requirements might change over time. But the first thing that I will ask you to submit is a project description, right? It'll be something that describes lots of nouns, lots of verbs, relationship between these things, and how things work. And then in the following project assignment, I'll ask you, okay, well now provide to me a UML class diagram that goes along with your project, right? So ideally, what we're doing for the lectures and in these assignments, you would then practice it on your own project, right? That's the idea. You practice it on a canned example, and then you apply it to your own set of projects. Okay. All right.